Now that we know how to add signed numbers, it's time to think about subtraction. Why? Well, the same sorts of questions that led us to need signed numbers in the first place might lead us to need to subtract signed numbers. For example, if yesterday it was 7 degrees below 0 Fahrenheit, so negative 7 degrees Fahrenheit, and today it's positive 5 degrees Fahrenheit, what is the change? Well, remember that change is the final value minus the starting value. So the change in this case is 5 degrees today minus negative 7 degrees yesterday. Right? Now, when we say 5 minus negative 7 equals what, we understand that question as the opposite of addition. We understand that question as negative 7 plus what equals 5. And we can think about that on the number line. We draw our negative 7, and then the result that we want, positive 5. And the question is, what do we need to add to our negative 7 to end up at positive 5? Well, we take this vector and we move it so that it starts at 0, and we see that the result we want is positive 12. Right? And that's, again, that's intuitive, right? To go from negative 7 to positive 5, the temperature went up by 12 degrees, right? And that is what happened. It went up by 7 degrees to get to 0, and then another 5 degrees to get to 5. Good news. We do not need to learn a whole new set of rules in order to subtract signed numbers. Why not? Well, look what happened here, right? In order to go from negative 7 up to 0, we needed a change of positive 7. And then we needed a further change of positive 5. What we saw was that 5 minus negative 7, that was the same as 5 plus positive 7. And this always works. In fact, any time ever that we see subtraction, we can always rewrite it as adding the opposite. Even ordinary positive whole number subtraction, right? 9 minus 4. If we wanted to, we could rewrite that as 9 plus the opposite of 4. Now, 9 is larger, so our result is positive. These have opposite signs, so we want subtraction. Bigger minus smaller, 9 minus 4 is 5. We can also do this for subtracting two positive numbers when it happens to be written smaller minus bigger, right? This is 7 plus the opposite of 13. Opposite signs. 13 is further from 0, so the result is going to be negative. Opposite signs, so we want subtraction. 13 minus 7 is 6, so this is negative 6. Positive minus a negative. That's 6 plus the opposite of negative 4. Well, these are just positive numbers, right? Same sign. The answer matches both. It's positive. 6 plus 4 is 10. We can take a negative minus a positive. Right, that'll be negative 6 plus the opposite of 5. Same sign, both negative. Answer matches both. Add the numbers. 6 plus 5 is 11. Let's see. What's left? Well, a negative minus a negative. Minus 6 minus negative 8. Right, well, that's negative 6 plus the opposite of negative 8 is positive 8. Opposite signs. 8 is bigger than 6, so the result is going to be positive, right? Opposite signs, so we want subtraction. 8 minus 6 is 2. The result is positive 2. Now, this fact that we can always rewrite subtraction as adding the opposite, this is kind of cool because this means that we never have to learn any rules for subtraction. We can always think of subtraction as a funny kind of addition. When we're thinking about algebra, we will always think of subtraction as just adding the opposite. Why do we want to do that? Well, because that way subtraction just uses the properties of addition. We don't need to learn any extra properties of subtraction because they get all of the properties of addition by way of thinking of subtraction as adding the opposite.